But in the event that you had an engine anomaly, the remaining single engine was more than adequate to get it safely to its destination.
The thrust of one of the engines is more than the entire thrust of a B-52 bomber, just one of the engines. And that bomber had 8 engines. So that technology allows Boeing to build this airplane as a twin-engine airplane.
Boeing was determined to integrate the latest technology into every aspect of the airplane. The wings of the 777 are the most aerodynamically efficient ever developed for subsonic commercial aviation. The improved design of the wings allows the airplane to climb more quickly and cruise at higher altitudes than competing airlines. But the biggest difference was not in the wing design, but in how they operate.
Another thing, of course, is the wing designs. The composite materials make the airplane lighter and yet, maintain or even enhance the safety and strength of the components. Some of the other technology is the fly-by-wire.
Modern aircraft, for all practical purposes, are going to be, quote, fly-by-wire. Instead of having the old system in which you had pulleys and cables and rods to move from the control wheel to the aileron or the rudder or the elevator, you do it electronically. A computer operates it, and so the inputs the pilot makes don't go directly to the control surfaces at all. They go to a redundant computer system, and that makes the corrections.
You can actually send a control input from the control column through a wire as an electrical input through a computer that analyzes it, enhances it, and makes any kind of corrections, and to the actual control surface itself. A good example is banking the airplane. Normally, in normal operations, you don't bank the aircraft over 30 degrees bank. The computer will let you go to 35 degrees, and if you try to exceed 35, it will actually give you a opposite input. You can feel the control wheel trying to tell you this is too much.
Although the mechanics of the airplane are obviously crucial to its safety and success, creature comforts were also very much a concern of the 777 design team.
I think it's very important that we do what I call aggressive listening, which means not only you listen to what the customer says, but what they mean. Ways of making the passenger more comfortable. We had one airline say, can you put a hole in the floor to put a bag into? We weren't able to do that, but we were able to solve the fundamental need, which was to give the passenger more room for carry-on bags with a bigger bin.
Well, this whole interior is in response to what the customers asked us for. The dimension of the airplane, 5 inches greater inside than a DC-10, really is in response to the customer's input. And they said, hey, we'd like to have, in business class, 7 seats across with the 747 seats. If you do that, then we can have you at the same seating comfort at 7 across as the Airbus is at 6 abreast. Some customers said they like a Scoshamore room in tourist class for the most comfortable 9 abreast ever in the industry, or an acceptable comfort 10 abreast in some market segments.
One of the features most talked about is the luggage bins, which are designed to open downward, a break from the traditional design on other airliners. Boeing's pride in the interior of the 777 has made the plane a popular choice for passengers.
Essentially, to a person, everyone has said this is the best airplane for the passenger and for the airline operator that they've ever seen from the interior standpoint.
Few people travel without baggage, and the 777 retains an impressive cargo capacity in its lower hold.
This airplane has tremendous cargo capabilities, not only in weight capability, but also in volume. Large packages can be shipped on this airplane just because of its size. But as far as the tonnage, we can carry as much cargo in the belly of this airplane than you can carry in a DC-8 freighter, the entire freighter. So it's quite a machine. Again, getting back to the productivity of it. It can carry a very large quantity of cargo, and that's a lucrative part of the business.
In the early spring of 1994, after nearly 4 years of intense design, development, and construction, The first 777 was nearly complete. Planning the ceremonial rollout of the first 777 was almost as difficult as building the airplane. More than 50,000 people had worked on the project, and with each person allowed to bring one guest to the ceremony, the total crowd would exceed 100,000. Therefore, on April 9, 1994, Boeing held 15 ceremonies, one on every hour from 6 in the morning till 8 at night. The plane stood still, but the crowds rushed forward for a closer look at this magnificent airplane. For 2 months after the rollout ceremony, Boeing engineers scrambled to ensure the airplane was ready for its first test flight. Loading and testing the more than 7 million lines of computer code had engineers frantically working around the clock. The airlines had already sold seats on the airplane for the following year, and thus the pressure to get the plane tested and ready was tremendous. Finally, on June 12, 1994, the big day arrived. It was time to finally see if 4 years of intricate design and development on computers would translate into success in the air. Orders for the airplane had to be met, and the tight deadlines were unforgiving. Any delays in the testing program would spell possible disaster for the company. The first liftoff and successful flight was a tremendous relief to the company, but the program was a long way from finished. For a year after the first test flight, 5 777s were used for a series of extensive in-flight tests. Delivery of the airplanes was less than a year away, and there was no room for delay. Each part of the plane had to be tested in a wide variety of environments and situations. The landing gear for the 777 is the largest ever incorporated into a commercial airplane and had to be rigorously tested. The main landing gear is a standard two-post arrangement that features 6-wheel trucks instead of conventional 4-wheel units. With a total of 12 wheels, the weight distribution is easier on the runway, taxi areas, and on the airplane. The 777 was tested for emergency takeoff under strenuous conditions. Here, a 777 is tested for minimum speed takeoff, a metal support cushioning the damage to the airframe. The brakes of the 777 had to meet specified requirements so that the airplane can abort takeoffs at very short notice. Bringing more than 500,000 pounds of metal, fuel, and passengers to an abrupt stop is not an easy task. A 777 was throttled to takeoff speed and then stopped as quickly as possible. The heat from the brakes was significant, yet the airplane matched all expectations.